Alright, this is my video for rendering and graphics assignment 4. Starting off with question number 1. In the shaders folder we have the new color selected 3D optimized, which has a C buffer WBP data with a matrix for the world view projection and a float of the selected color. And then if we look inside of the shader color, we have a struct of the matrix of the world view projection as well as the color, and then a buffer to store that in, and we have a function to send those values. So looking in here, we take in the world matrix, the view projection already computed, and the color, and we set those, multiply those together to get the world view projection, and then submit that to the resource. And looking inside of the actual app function, we see we set our view projection by multiplying the view and the projection, and then we send all of that to the collection, and then we call the render on that. So if we're looking in here, we'll see we'll get the same cube, just render or computing our matrices on the CPU. And if we move on to the second one, using the same HLSL, or relatively the same one, I'll spawn in 5 cubes with their world transforms multiplied by a transpose to move them over. But if we look at this one, we will compute the full WVMP before sending it to be compiled. So if we look at the color selected, it's the same thing in here because we've already computed, but in shader color we're now taking in a single matrix of the already computed world view projection, and then we'll just set our values in here, computing in the draw function. To run this, it'll be the same cube, just 5 of them. So we move this over, we now have our single cube and then 4 additional cubes rendered with offsets from the origin. And looking at question number 3 of the pyramid, inside of the model tools we have a new function for the create unit pyramid, taking in the variables. And then inside the create unit pyramid, we create all 4 triangles of the sides and then the square down at the bottom. And then we set all of the tries down here, and then we set the UV values so that we get the texture to display properly. And then looking at the DX app, we'll load in the pyramid num.tga, and then we'll create a unit pyramid model. So if you run this, so we see we have our pyramid here, the texture on the sides, same texture on all the sides, and then down on the bottom we have the square texture. If I can get it to go down, there we go. And then Looking at number 4, we have another function, new one, for the create unit box, which will just be a standard box. Or not create unit box, create unit 6 face texture is the new one. Uses code similar to just the unit box repeating texture, except with specific UV values to map the faces to the correct coordinates in the UV grid. And then in the DX app we are calling the unit box 6 face texture with the image a.tga. So if you run this, got the cube here with the back side, the right, left, there's bottom, and then the top is up here. And I do not have number 5, but looking down at the further work, looking at the standard unit box with the different textures, no matter what you run, I'll always get solid colors all across. And it's because if we're looking in the model tools, when we create unit box, we don't have any sets for the UV values, so whenever it's rendering, it will grab whatever color pixel is at 0, 0 in the UV map, and that color will be displayed all over, so you'll get full brown or full red models. And looking at the performance tests, computer CPU usage isn't too bad. It looks like a lot of what is the biggest drain is the draw scene of rendering everything, with a lot of it being the render from inside the scene. And then my computer is always slow with launching debugging or anything within Visual Studio. But that is it.